Okay, so how would you solve this equation? What is the first thing that it is preventing you to reach the value of x? Okay, what would you want to do here first? Our goal is to reach x so we can get its value, or we can find its value. So yes, the first thing that we need to do is to move negative x. Negative 6 is to move negative 6. Okay, you don't want to put negative 6 in the exponent. Okay, so Rachel is saying move negative 6 into the exponent of the argument of 5x. That's okay. That is not incorrect because Rachel is using the power property to bring the factor of negative 6 into the exponent. The problem, Rachel, there is that you will make the argument a bit more complicated, because then you will need to be working with 5 raised to the negative 6. So you don't want to do that. What I would suggest to do first is to divide both sides by negative 6. That way you cancel this factor of negative 6. And then we have log base 4 of 5x equals to 2. Okay. Rachel, doing that, you will get once isolated the logarithmic function on the left side, but with a negative 6 on top of 5 and x. Okay, and Tristan, I think you wanted to subtract the logarithmic function by 12. I'm not so sure what you wanted to put there. Okay, but this is how you want to solve this, or how you want to isolate the logarithmic function on one side of the equation, by dividing both sides by 6. Okay, it's the easiest route. So now we need to cancel that logarithmic function. Before we move, any question with the first step that we did here? Okay, so how would you cancel this? 4 raised to the power of 2 equal 5x. And this is something that you can solve. Okay, what will be then the value of x? Okay, when solving here, what is the value of x? 16 divided by 5. And that is the written word. Okay, any question with this one? All right, so we are continuing solving logarithmic equations. But now we are going to introduce, so we are ramping up like difficulty here, but we are going to continue using the same properties and the same strategy. So I have here log base 2. And no, Rachel, I hope I can get early, but we are going to stay here a little bit more because you will see different type of exercises that we need to cover. Okay? But I'm recording the class, so if you need to leave, that's okay. Okay, in this exercise, you want again to isolate the logarithmic function. What's the problem? The problem is that you now have two terms with logarithmic functions. Okay. So that's okay. If you need to leave, that's okay. I'm going to continue. I will pause the recording. So don't worry about that. Okay. In this case, since we have two logarithmic functions on the same equation, the first step that you want to do here is to combine these two, if it is possible. Because we are seeing that we have the same base on both logarithmic functions, that is going to be possible because we have the product property or the quotient property. So adding both sides by log base 2 of x, see that we can now cancel this here, and then doing the same on the other side. We get the following. Okay, and careful here because now we will be working. We are going to solve two problems here. Okay, you will see how we become into two problems. Okay, so the first thing that we can do here is, since we are adding these two logarithmic functions and they have the same base, you can use the product property to combine both. Okay, so what you are going to do is to take the two arguments and you're going to multiply them. Okay, so here we have a big, huge argument for log base 2, where we have two linear factors that are multiplying together. This is equal to 3. Okay, so then you want to cancel the logarithmic function. Now we have simplified, we have isolated the logarithmic function on one side of the equation. So what we want to do here now, so we want to cancel the logarithmic function. So that is 2 raised to the power of 3 equals x plus 5 times x plus 7. And this is the second problem that we have here. So the first problem is the logarithmic problem, the original one. Okay. Now we are dealing with a quadratic problem. Careful here, because from the quadratic problem we are going to get multiple solutions, but not all of those solutions are going to be solutions to the logarithmic problem. So we know how to solve this because we have been working with this. So this is 8, and here this is x to the power of 2 plus 12, yeah, 1235. So we have a quadratic equation here. We want to solve for x. We know how to solve for x here. We know that we need to have a 0 on one side of the equation, so I'm going to subtract both sides by 8. Okay, so that way we can use the method or the techniques that we have learned. I'm going to put everything on the left side, 0 is going to be on the right side, just flipping the order, okay? So x squared plus 12x plus 27, this is equal to 0. So we are dealing with a quadratic equation. We can use the polynomial properties that we know to do this. So we have 12 and 27, that is 9 times x plus 3 equals 0. So the solution of the quadratic equation is -9. Let me put this in order. -3 and -9. Careful. This is the solution for the quadratic equation. So from the quadratic equation, we got two solutions. Now, we need to see if those solutions are also solutions for the logarithmic function. How are you going to do that? Evaluate the quadratic solution for the log problem. And why here we need to make a distinction between the quadratic equation, the quadratic solution, and the logarithmic problem? Because if we go back to the property of the logarithmic functions, we know that the domain of the logarithmic function is from 0 to positive. So that means that log have a restriction on the argument. So the restriction is the following. Argument need to be greater than 0. Okay? So it means that, going back here, what argument do we have here? We have, let me copy this again. Okay, so that is this is the original problem here below. The possible solution that we have. The solution from the quadratic problem are -3 and -9. There is a big restriction here for the logarithmic functions. Argument need to be greater than 0. Okay, Tristan. If you plug in -3 on both arguments here, you are going to get a positive value, for example. Let me just put the argument here and just evaluate with the possible solutions. So I'm going to create a table here. The possible solutions are -3 or -9. If I use -3 with -5 with x plus 5, I don't care exactly what value is that, but I know that is going to be positive. The same for x plus 7. This is going to be positive. So yes, -3 is a solution. Now let's see what happens with -9. -9 plus 5, this is going to be negative. Here we're going to stop with this, that when we plug in -9 into the argument of x plus 5 and we get an argument that is negative, less than 0, with only this, we know that negative 9 is not a solution of the logarithmic problem. Hence, the only solution here is x equals negative 3. Careful with this kind of problems because there brings multiple layers of the original problem. So like this, in this one, we got a quadratic problem inside the logarithmic problem. We solved the quadratic problem, and then we need to get back to the original problem. And we need to evaluate if the solution for the quadratic problem holds into the logarithmic function or into the logarithmic problem. Okay? So careful with this type of exercises. In our class, you will get quadratic equations. And in the logarithmic functions, okay? This one here, now we are going, again, we will need to combine. Again, if you have any question, feel free to stop me anytime. So we have here a logarithmic function or logarithmic equation with logarithmic functions. We are seeing that all three logarithmic functions share the same base. The base is e because we have natural log. So our goal here is to isolate or to simplify the logarithmic functions in a way that then we can find or solve for the unknown variable, which is x. The unknown variable is here. And what I'm going to do here is, since we have the same base on the right side for both logarithmic functions, and we have a subtraction, I'm going to use the quotient property here. Using the quotient property, I can combine the two arguments into this fraction. And I can go further and try to eliminate, well, we are going to eliminate, yes, at this point we are going to eliminate the logarithmic function. But what I'm trying to say is that at the beginning, I wrote this property. So I want to use this property to solve this equation. Because what we are seeing here is that we have natural log on both sides. Okay? So that means that 7 equals x minus 7 or 2. And this is something that you can solve. Okay? Here, what you will do is to multiply both sides by 2 and then add both sides by 7. The value of x is going to be 21. Okay? I'm not putting those steps here in the middle, so you can to leave you to find out to figure out what steps those are, or to write down those steps and to reach the same conclusion. Okay? If you are working on the test and you have something like this, remember that you need to add those steps on your written work. Okay? But here I'm just showing you how to deal with the logarithmic function and giving you just the final solution. So then you can compare your work with the final solution. Okay. So this one, pretty easy. Okay. As long as we use the properties correctly, I don't believe we need to have like big issues here. I'm going to skip that one. And this one is interesting. I don't know. Well, no, you are going to have questions about this one, so I'm not going to skip that one. But what I'm going to do here, I will try not to explain too much. I'm just going to show the steps. So then you can figure out, or maybe you can compare each step or evaluate each step and then try to figure out what property I'm using. Okay, so my first step here will be okay, so that's my first step. This is why. Find a solution there. Okay, so I have used the properties that we had discussed. I believe I use the quotient, I use the power property, I use the product property to simplify this logarithm expression into one logarithm function. Okay, remember that we need to have the common base within all the logarithm function in order to use the properties. So here is how you solve this one. But like I said, I didn't explain anything. I just showed you the steps. You have questions about this one or this type of exercises. This might be tedious and complicated exercises because of the algebraic work. If you do something wrong, your entire exercise is going to be wrong, even just a negative. So careful with these ones. These are good to practice how you apply the properties. Okay. So I'm gonna leave there. Let's move to the next one. Okay, and the last three exercises are what happened. So in unit number 10, we solve exponential equations by the following property. See if I can write the correct property. So if we have exponential expression, our goal in unit number 10 was to first find a common base between the two exponential expression on the equation, and then use this property. Basically, we're canceling those common bases and taking the exponent and putting them in an equation itself to solve for the variable. What's the problem here? That this property can be used because 6 and 11, they do not share a common base. So I have now the following problem. I don't have a common base between 6 and 11. But that's okay, because we know that the inverse operation of exponential operations is logarithm functions. So we can use logarithm function to cancel the exponential problem. This is an exponential problem because our unknown variable is on the exponent. So we need to find a way to bring down the exponent on the level of the factors where we can solve for x. There are three options here. What you want to do here is to use logarithm function on both sides of the equation, to use the power property and bring down that exponent. You have three options. or main, you have infinite amount of options. You can choose whatever base you want to use. Okay, for the logarithmic function. For the two common methods here to solve this exponential equation is by using log base 10 or just log, or natural log. These two are good methods because on your calculator you will see that you only have log base 10 or log natural log. Few calculators allows you to use a different value for the base of your logarithmic function. Okay, so there are three ways to solve this. I prefer this one, the one that I will choose my own base for the logarithmic function, and you will see why I prefer to use that one. What will be the problem is that if you need to get an exact value at the end, and your calculator doesn't have the function to add a different value to the base of the logarithmic function, then you will be stuck unless you change the base. So let me show you a few tricks on how to do this. And let me show you why I prefer the third method rather than the first. So I'm going to do method number 2 and method number 3. Method number 2 and number 3, and number 1 are basically the same. The only thing that change is the notation, okay? But they are exactly the same. So let me start by solving with natural log. So what you want to do is to put both sides of the equation inside, use them as the argument of natural log. Okay, that way you are going to cancel, in a sense, the exponential part, the exponential expression, because now, well, yes, you are going to cancel the exponential part, because now we are going to use the power property of the logarithm function. So now the exponent, let me highlight the exponent. The exponent goes down. So x plus 7 times natural log of 6 equal natural log of 11. Remember that natural logs are just numbers or values. So treat them as they are. This is a factor. Natural log of 6 is a factor. So that means that you can divide both sides by an ln of 6. So you cancel this. Now you are with this. Okay. And then x, subtract both sides by 7, and you got the following. Okay, that's using ln, natural log. It will be exactly the same to just log base 10. I'm going to solve now using a different base. The base that I'm going to select here is when I evaluate or analyze the exponential expression that I have, I see that the base of the exponential expression here is 6. So I'm going to use log bases on both sides, and you will see what happened here. So now using log base 6, okay, again, the step is exactly the same. using log base 6. So I bring down the exponent using the power property. But look what happened with this factor here. I want you to focus on log base 6 of 6. What is the value of that? What happened with that? So what's happening with log base 6 of 6? When we have a base, the logarithmic function has a base that is equal to the argument, that value is 1, so we cancel this out. Now we have only x plus 7 equal log base 6 of 11. And then we go and subtract both sides by 7. And this, let me put this side by side so you can compare what's happening here. Maybe I should put this a little bit up. Maybe this goes up. Okay, and there you have it side by side, the two methods. The solution is exactly the same. You can check by your calculator. Using the calculator, you can check that they are exactly the same. But if you want to get back, the problem here is log base 6. If you want to get back to log, that if you are in, you use the second method here, and you want to get, you want to evaluate log base 6 of 11, but you are working with a calculator that doesn't allow you to use a different base for the logarithmic function. How can you evaluate log base 6 of 11 in your calculator? Well, there is something that it is called change of base, and we have a formula. So we have log base of A of B. So we can change to any base that we want using the following formula. Log base C is going to be the new base. We don't know exactly the value of C. I will zoom in just in a moment. So you will do log base of the argument divided by log that new base of the original base. Let me do an example here. So we want to change log base 6 of 11 to natural log. So what you are going to do is ln of 11, ln of 6, and that's it. And that's how you turn log any base to a different base. For example, here log base 6 of 11 is the same as log natural log of 11 divided by log natural log of 6. And you can see that I have here log base 6 of 11 is the same as natural log of 11 divided by natural log of 6. So there you have it. Those are the two methods, or three if you count this as two, because ln or log is the same. Using algebraically are the same. So this is how you want to solve these exercises. Again, if you need to give an exact value, so here you want to round to the nearest hundredth the last the last answer, use the calculator that you have on Alex. With that calculator, it's going to be easier to write down these computations. Okay, our calculator, the regular calculators, are the display is not the best one. It's not so friendly to add this type of calculations. Okay. Okay. Another one. Again, we need to bring down the variable, which is in the exponent, into a level that we can solve for it. All right, so here 6 and 13, they do not share a common base. Both of them have an variable, the variable x, in the exponent. So you want to cancel those. But that means that you can use log base 10, natural log base 6, or log base 13. So how are we going to choose the best base to use here in order to have the optimal route of solving this problem? In my opinion, because now I'm going to evaluate the exponents, and I believe the exponent with negative x minus 9 looks more clunky, or maybe more complicated than 3x, because in 3x we have just a multiplication, but in the other exponent, negative x minus 9, we have a negative. We have two terms in the exponent. So I believe that one is going to be a little bit more difficult to work with. So for that reason, I'm going to use log base 13, because when I use log base 13, I can eliminate that 13 there. Okay, if you use log base 6, is going to be exactly the same, but the only thing that you are going to be canceling then 6, and then you are going to be dealing with 13 and the two terms of the exponent. So I'm going to use log base 13 on both sides of the equation. Using the power property, you can bring down those exponents down. Log 13 of 6, obviously we cannot cancel it. But what I was interested, or my goal was to eliminate this one, because this exponent has two terms. Okay, so for me it's more difficult to work with negative x minus 9 rather than 3x. So here we have 3x log base 13 over 6 equal negative x minus 9. So we are dealing with xx. We have multiple x, so we need to put all the xx on one side of the equation. Now we can factor out the x, because we have two terms, first term and second term. Remember that we have addition there, that's separated terms. So x 3 log 13 of 6 plus 1, okay, equals negative 9. You can see that this all this is a factor, so that means that we can divide by it. By dividing the entire equation by 3 log 13 of 6 plus 1. Okay, we cancel this. we got negative 9 over with the negative. Okay, so that's the answer. A clunky answer to write down. We don't know exactly that value, but we can use the calculator. Okay? And again, you want to change the base. If you are using a calculator that doesn't allow you to use 13, Alex doesn't allow you to use 13 as the base. So what you want to do is to put natural log of 6 or log natural log of 13. Okay? And that way you can evaluate the value of natural log base 13 of 6. Written work of that exercise. Okay. So this one is, you're going to do the same. You're going to select the method that you want to use. Careful with this one because at the end, the exercise is asking to write the exact answer. That means that you don't need to evaluate the exact value at the end, like with the two exercises before. In the two exercises before, you needed to round the final answer to the nearest hundreds or the decimal places that they're asking. Here, you need to write the exact answer. The exact answer will be an answer where you are going to use log base. In this case, you are going to use log base 10 or log base e. The exact answer on the previous exercise is this one is the exact answer. Okay? Because I just writing the expression of that value completely. Okay, so that is the exact answer. If this exercise would in this exercise I would need to just post the exact or to submit the exact answer, I will do the same. The only thing that I will do is that I change log base 13 to log natural log 6 over natural log of 13 because the exercise is going to ask me, is asking me to put my exact answer in log base 10 or log base e or natural log. Okay? So when the exercise asking for exact answer, you don't need to evaluate. You don't need to use the calculator. Just put the expression that you got at the end of the result, following the bases that are that the exercise asking. Base 10 or base e or natural log. Okay? I'm not going to solve the last one because it's repetitive. It's the same process. Here, the difficult part is working with the notation of logarithm function. They are a bit clunky, a bit tedious, and very easy to mess up with the letter log. Okay, careful with that. Careful with the exercises. With the signs, negative are here are important. Remember always to show all your steps like I did here. This is the complete written work of this exercise. So yeah, prepare. This Friday is quiz number 5. It's about this unit that we discussed. You want to practice how to solve this type of equation a lot so you can feel comfortable when working in a quiz on the test. Okay. Any question before we finish our class? All right. If there are no questions, thank you one more time for being here. I think you are ready now to finish the your homework from 10 to 12, sorry, 10 to 12 in Alex. You are ready for that. You have all the recordings. If you have any questions, just send me an email. I will be happy to help you. Okay. So thank you and goodbye, everyone.